Hey everyone, Mr. Voikin here. We're going to take a look at lesson 9, the last lesson in unit 6, and we're going to be solving polynomial equations. So up till now, we've just been dealing with expressions, and the difference between an expression and an equation is basically this thing right there, the equals sign. So in this case, we have taken that expression and made it equal to 0. So you should be able to notice that we've got in this case, 4 binomials, and we should be able to factor those out. So in each case, we've got x squared. So what we're trying to do is figure out what is the value of an x. Now later on, we'll learn that when we have x squared, in an equation like this, it's going to turn out to be a parabola. And a parabola is a shape on the XY coordinate system that is going to look something like this. Okay, and at this point and this point, where the y is equal to 0, because remember this is y and this is x, at this point y equals 0. And what is the value of x right there, and what is the value of x right there? So this parabola, which is different than, say, a straight line like this, it passes through the x axis at 2 points, one being there and one being there, whereas a straight line will only go through one time. So in this case, we're going to have 2 possible values for our x. So let's start off with the first one. So when we see this, we need to factor this down so that we have something that states x is equal to. Okay, so x minus 81 equals 0. Well, if we just sort of ignore the equals 0 right now, we're getting back to where we were, where we would recognize that this one is just going to be a difference of squares. So we're going to have x minus and plus and 9 and 9. So in this case, what we end up with is x minus 9 times x plus 9 equals 0. Don't forget we had that equals 0 thing. And what I can actually do is just sort of separate this out a little bit. So if I say here that x is going to be 9, this ends up being 9 minus 9 right here. So 9 minus 9 equals 0. So that's true. And in this case, if we made x equal to negative 9, we would have that negative 9 plus 9 equals 0. So once we've broken it down like this, we can basically state that x minus 9 equals 0, therefore x is equal to 9. Because basically what we're doing is just standard algebra, where we're going, let's isolate the x on the left and move all the numbers to the right by going plus 9 on both sides, and this cancels and we're left with x equals 9. So following that theory, if x minus 9 equals 0, and in that case we can come to the conclusion that x equals 9, if we have x plus 9 equals 0, then x is going to be equal to negative 9. So in this case, x is equal to positive or negative 9. Okay, and that would be the final answer for A right here. And let's move on to B. So B says 4x squared minus 9 equals 0. So let's write this down right here. 4x squared minus 9 equals 0. So again, we've got a difference of squares. It's going to equal 0. And in this case, it's going to be 2x minus and plus 3 and 3. Okay, so I just want to make sure that I copied that down correctly. Good. Okay, so in this case, what's different from the last one is I've got this value of 2 in front of that x. But again, it's just basic algebra. So if I take this and isolate it as 2x minus 3 equals 0, I'm going to add 3 to both sides, which is we're going to end up with 2x, these cancel, equals 3. And then I'm going to divide both sides by 2. Again, this will cancel. And we're left with x equals 3 over 2. So you can see that it was a negative 3 right here, which was brought over to here and became positive, and then we divided by 2, so it became a positive 3 over 2. So again, looking at the other one right here, if I follow that, then x should equal, on this one, x should equal a negative 3 over 2. So another way to write this is that x equals positive or negative 3 over 2. Okay, the next example, C 10x squared minus 90x. So C would be 10x squared minus 90x equals 0. So in this case, there's something that can be factored out, and we want to do that at first. So what can I pull out of here? Well, a 10 and an x are common. So I'm going to pull a 10 and an x out, and that's going to leave me with an x minus 9. Okay, now in this case, when we have x minus 9, we want to check to see, is this a perfect square? Well, 9, we can take the square root of 9, but we cannot take the square root of x, so we're finished at that point. Don't forget that it equals 0. So before we had two sort of binomials in brackets, but we still have two different terms right here, and they're going to equal 0. So I have 10x equals 0. So how am I going to solve what x is? Well, I'm going to divide x by 10, or this one by 10, that one by 10, canceling this out. So I get x equals 0 divided by 10. So in that case, x equals 0. I'm going to take the binomial right here, which is going to be x minus 9 equals 0. And from our previous examples, if x minus 9 equals 0, therefore x is equal to positive 9. Once we bring this negative 9 over to that side by adding 9 to both sides. So in this case, x is going to equal 0 and 9. All right, and last example here is going to be 10x squared minus 90. So let's write this down. That's going to be example D. 10x squared minus 90 equals 0. So again, we have something that can be factored out here. Let me just double check again. 10x squared minus 90. 10x squared minus 90. Okay, so what can I factor out? Well, I can factor out a 10. What does that leave me with? An x squared minus 9 equals 0. Okay, and if you notice inside here, I've got possibly a perfect or a difference of squares right here. So we got negative 9 and x squared. They can both be, we can take they're both perfect squares. So we're going to be able to break this down into something like that, where I'm going to have x minus plus 3 and 3. So now in this case, if we sort of have three different things here. So we got 10 equals 0. Well, that's not true. So we really just sort of ignore that 10 because it doesn't have an x with it. It's just sort of pulled out as a common factor. But we do have, in this case, the x minus 3 equals 0. Therefore, x equals positive 3. And x plus 3 equals 0. Therefore, x equals negative 3. And a proper way to write this would be x equals positive or negative 3. Okay, now moving on to our next example 3. We have another equation here, again denoted by the presence of that equal sign. So let's take a look at the first one here. I've got 3x squared minus 13x minus 10. Now we've seen this expression up to this point, but they turn it into an equation by saying, let's make that equal to 0. Now I just basically need to factor this out because I have this sort of squared there. I need to get rid of that so that we have something that's saying x minus 4 or x plus 9 or something like that. Okay, so we want to take a look at this first and see, can I factor something out of each of these? And the answer is no, nothing is common. So what are we going to do? We are going to just follow the procedure of multiplying the leading coefficient by the constant, and we get 30. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. And we're looking for two numbers that are going to subtract and equal 13, and the larger of those two numbers will be negative. So that would be this one right here, 2 and 15. 15 minus 2 is 13. And like I said, the larger number will be negative, so the 15 is negative, the 2 is positive. And what do? Well, we keep the first term, we keep the last term. So we've got 3x squared. I got a negative 10 down here. Don't forget it equals 0. It's an equation. And I've got a 15 and a 2 to place. Well, 15 pairs up with the 3 better, so minus 15x. That'll be one of our groups. And I got a plus 2x. That will be our other group. At this point, I want to try to factor something out of here and out of here. That's going to be the same. So if I look right here, I can factor out a 3 and an x, leaving me with x minus 5. And if this is factorable, it means that this one down here will also have an x minus 5 in it. It equals 0. What did I divide this by to get to negative 5? So negative 10 divided by 2, a positive 2, equals negative 5. So essentially what I'm going to do is factor out a positive 2 out of this one. And I'm just going to double check with the first term of that binomial. Positive 2 divided by 2, positive 2x divided by 2 leaves us with the x. So everything is good. Now I'm just going to rebuild everything. So I've got an x minus 5 and a 3x plus 2, and we make that equal to 0. And like we did in the previous example, if x minus 5 equals 0, I can conclude that x is equal to positive 5. And if 3x plus 2 equals 0, I can conclude that x equals a negative 2 over 3. And again, that can just be calculated very quickly by doing basic algebra. I'm going to add 5 to this and add 5 to this side, and then we got our statement, which is true. And this one I would subtract 2, canceling this, divide by 3, and we're left with what we have over here. So basically what we've got here is that x equals negative 2 over 3, and it also equals 5. Okay, the second example, 5x squared plus 30x. I may need to add another page in here. So we got 5x squared plus 30x equals negative 25, I believe. 5x squared plus 30x equals negative 25. So this one's different in the sense that every example I've done to this point said it was equal to 0. But again, we can sort of revert back to that form by just adding 25 to both sides of this equation. Okay, so I'm going to add 25 to this side. That's going to cancel to balance things out. If I add 25 to the right, I got to add 25 to the left. So what we end up with now is 5x squared plus 30x plus 25, and that's going to be equal to something still. Negative 25 plus 25 is 0. Okay, at this point we want to, we can see that the a, the number in front of the coefficient in front of the x squared, so our leading coefficient is not 1, it's 5. So the first thing I want to see is, can I divide this, this, and this by a common factor? The answer is yes, I can divide it by 5. So we're going to take that and we're going to pull out a 5, leaving us with x squared plus 6x plus 5. And don't forget, it's an equation, so we need the equal sign. It equals 0. At this point, we got the 5 out here, and because the a in front of the x squared is 1, we should be able to just break this down into two binomials that equal 0. So I've got an x and an x. These signs are the same, and they're both positive. So I'm going to go plus and plus. And I need to find the factors of 5, which is only 1 and 5. They need to add together to equal 6. So 1 plus 5 is 6. Everything works out perfect, so I can put a 1 and a 5 right there. Now, if you remember from a previous example, there's not an x tied to that 5 that's on the outside of these brackets, so that is not going to be part of our solution, but we are going to have x equals -1 and x equals -5, and can be written as x equals -1 comma -5. Okay, and we're on number 4. So we got a word problem, and all we got to do is analyze the information within the word problem, probably draw a diagram, and then place our values where they would fit inside that diagram, and then try to determine a way that we're going to solve this. So what do we have at first? It's telling us that we have an area of a rectangle, and the area is 300 centimeters squared. So if we just draw a, not like that, we use this. If I just draw a rectangle, I can state that the area is 300 centimeters squared. It tells me that the length, okay, so the length of that, just wait, let me switch over here. The length is 5 more than the width. So the length is 5 more than the width. So essentially they didn't give me any real numbers, so I'm going to have to just choose something. So this would be my length and this would be my width. And I'm just going to assign this length a value such as x. Now, if I made them both x, they're not the same. So that's impossible. You can't say this is x and that's x when they're not the same. But it says up here again that the length is 5 more than the width. So if the width happens to be x, if the length is 5 more, then the length would be x plus 5. Now, so what do we know about area? We said that this is the area right here. Well, we know that area equals length times the width. And what are we trying to actually determine on this question? Form a polynomial equation to solve it and determine the perimeter. So we got to make a polynomial equation and solve the perimeter of this sheet. Okay, so let's take a look at what we've got. Well, if I take a look at this formula that's up here, area happened to be 300 equals length, which is x minus 5, times the width, which is x. So I can sort of take these right here and combine them together. So I'm going to get x times x, which is going to be x squared. X times negative 5 is going to be negative 5x. And it still equals 300. Now remember what we did up here. It was equaling negative 25 right here, but I just sort of moved it over to the other side to make it equal to 0. So I'll do the same thing right here. I'm going to subtract 300, canceling this, and subtract 300 from this side. So now I'm down to x squared minus 5x equals, oh no, minus 300 equals 0. So we have a trinomial set up where the value of a is 1, and now I need to break this thing up into two binomials that are going to equal to 0. So what I need to do are find the factors of 300 that are going to subtract to equal 5. Okay, so what do I have? Larger number, you might have to pull out a calculator. So I've got 301, I've got 150 and 2, I've got 103, and if I take 300 and divide it by, say, 5, we're going to get 60. If I divide it by 6, I'm going to get 50. And we're trying to subtract these two, so 50 minus 6 is not equaling 5. So I got to keep going and finding something else. So let's try 10. So if I was to have one of the factors as a 10, the other one would be 30. And again, this still doesn't work out because 30 minus 10 is 20. So what if I made a 15 right here? So I got 300 divided by 15 is going to be 20. And now if I look at this, 20 minus 15 equals 5. So this is what I want right there. Now, notice that the larger number should be negative, as indicated right here. So what I would actually want to do is make the 20 negative and the 15 positive, equaling negative 5. Now this trinomial can be broken up to x. The signs are different. The 20 goes with the negative, and the positive is with the 15. And just like we did before, I have got x minus 20 equals 0. Therefore, x is equal to 20. And I've got x plus 15 equaling 0. Therefore, x is equal to negative 15. Now, although there are two possible solutions here, you got to remember that we're dealing with a length and a width. Can a length or a width be negative? The answer is no. So we can't use that one. So that only leaves us with this one right here, which is x equals 20. Okay, so we've sort of solved the first part of our word problem by creating this polynomial equation, but now it says solve for the perimeter. And what do we know perimeter is? Well, it's going to be, in this case, length plus width plus length plus width, the distance all the way around this shape. So essentially what we've got is x plus 5, which is our length, plus our width. Okay, so x plus 5 plus our width is x, plus another length, which is plus x plus 5, and plus another width, which is going to be x. Now there's obviously faster ways of doing this. I can set this up as 2 times x plus 5 plus 2 times x. Okay, or I can set this up as x plus 5 plus x and multiply the whole thing by 2. Okay, now either way, whichever way you set it up, we still need to substitute this x with a number which we calculated to be 20. So really what we end up with is a 2 times 20 plus 5 plus 20, and that is going to equal our perimeter. And now I just need to punch it into the calculator the way I lay this out. So it's going to be 2, bracket, 20 plus 5, close the bracket, plus 20, close the other bracket, and we get the perimeter equals 90. Now don't forget, we're dealing with a length. It usually has units. What is it saying here? Centimeters. So in this case, it needs to be centimeters, no squared, no for like that's for area, and not cubed because that's for volume. So the answer in this case is the perimeter equals 90 centimeters. All right, so that's it. That's all the class examples we have for this lesson. We are not going to have a at-home assignment due with this one, but obviously if you're at home, I would encourage you to start working on the assignment in the book, which I'm not sure what page that starts on. If I take a look here really quickly, looks like it's on pages 379 to 382. All right, we'll see you in class and we'll work through these questions together.